The Earth is located in the Milky Way galaxy. It is the third planet from the Sun. It takes 8 minutes for sunlight to travel from the Sun to the Earth.
Planets we come up with are 8: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You'll notice that these bodies tend to follow the same path in the sky called the ecliptic, and they orbit the Sun in the same direction. That supports the leading theory of the solar system's formation.
Pluto was once classified as a planet but no longer is and is considered more of an asteroid.
Scientists have theorized that the metals in our universe are the result of stellar nucleosynthesis. This theory states that after the first stars formed, heat and pressure in their interiors led to the creation of heavier elements, like silicon and iron. These elements not only enrich future generations of stars' metallicity, but also provide the material from which the planets formed.
The Earth consists of 7 plates, which are called plate tectonics. Plate tectonics were just recently discovered in about the 1970s. The North American and Pacific plate are in California. This is what is called a subduction zone.
A collision which took place between two neutron stars billions of years ago produced a considerable amount of some of the Earth's heaviest elements. These include gold, platinum, and uranium, which then became part of the material from which Earth was formed.
The Earth is a rocky planet with a solid and dynamic surface of mountains, canyons, plains, and more.
The planets are all on the same plane and orbit the same direction.
Scientists have speculated that it is possible to have a naturally occurring nuclear reaction. This occurred in Africa billions of years ago and still may be seen. Located in a site called Oklo, Gabon, there are 16 sites at which self-sustaining nuclear fission reactions are thought to have taken place approximately 1.7 billion years ago and ran for a few 100,000 years, averaging probably less than 100 kilowatts of thermal power.
A neutron is absorbed by a uranium-235 nucleus, turning it briefly into an excited uranium-236 nucleus. With the excitation energy provided by the kinetic energy of the neutron, plus forces that bind the neutron, the uranium-236 in turn splits into faster-moving lighter elements, fission products, and releases a small amount of free neutrons. At the same time, one or more prompt gamma rays, not shown, are produced as well.
Weapons-grade uranium is derived from U-235 and converted into U-238. This is done by the gaseous diffusion process.
In nuclear physics and nuclear chemistry, nuclear fission is a nuclear reaction, or a radioactive decay process in which the nucleus of an atom splits into smaller, lighter nuclei. The fission process often produces free neutrons and gamma photons and releases a very large amount of energy even by the energetic standards of radioactive decay.
Energy was harnessed and demonstrated in 1945 at a site called Trinity. This energy was used on Japan at 2 sites, Hiroshima and Nagasaki, one using the gun method and the other the implosion method, using TNT lenses to detonate the bombs. Nations ended World War II. This is the end of part 1 of our series on the universe. Stay tuned for part 2, and thank you for viewing.